I did one word problem. All right, so guys, everything will be based off the homework. So all I'm doing will be from your homework packet. So go ahead and just take that out. All right, so let's go ahead and get started. So I'm starting with number 5 in your packet. That's the let me double check that I'm recording. Okay. So I'm starting with number 5 on the packet in your homework. It's a graphing problem. So I have -2x plus 4 all squared plus 5. What I want to do here is I always want to start with my vertex. My vertex is -4, 5. So that's going to be right here. So I can make like a little table, a little XY table. And I'll put -4, +5 right in the middle. And I want to graph 5 points. I'm going to choose two bigger than -4 and two smaller than -4. So I can go like -3, -2, -5, and -6, whatever it is. And I only need to solve one half of this because they're reflections of each other. So I'm going to take this x value, I'm going to plug it into the formula. When I plug in -3, you get -2 times -3 plus 4 is 1, 1 squared is 1. So you have -2 plus 5, which is a +3. And since -3 is just as far to -4 as -5 is to -4, they're reflections of each other. So that's also going to be 3. -2, when I plug that in, -2 plus 4 is a +2. 2 squared is 4. 4 times -2 is -8. -8 plus 5 is -3. And since -3 and -6 are reflections of each other, they have the same y value of also being negative. Then we can go ahead and just plot it. I have -2, -3, -3, 3, and the reflections. Any questions about that? Does that make sense? All right. This problem also asks to figure out the domain, range, axis, symmetry, min-max values, and when it's increasing and decreasing. So now that I have my graph, though, figuring all that stuff out would be pretty easy. So the first thing is the domain. For quadratic, your domain is always going to be all real numbers. For the range, we can see my graph right here. I'm going from -infinity all the way up to my +5. So put that in interval notation, just like that. Axis of symmetry, we'll say A0S for short. Your axis of symmetry is always in the form x equals h. So in this case, it's x equals, what was it, -4. Min or max value. So your min and max value, that's going to be your k value. Because when it comes to quadratics, your vertex is always going to be your biggest point or your smallest point. in this case, my vertex is my biggest point right here, and your k value is going to be your maximum in this case. So in this case, I have a maximum at 5. And that's going to be your k value. Then from here, I need to figure out where am I increasing and decreasing. So where you're increasing, or anytime you ask where, we're always talking about your x's. So where am I increasing and what values am I increasing? I'm increasing from negative infinity to my h value of -4. And I'm decreasing from -4 to infinity. No, you shouldn't have a bracket, because when it comes to increasing and decreasing, you're never increasing or decreasing at a point. You're increasing or decreasing on an interval. You know, I always make the example of, like, you think of someone walking, right? If I'm walking towards you, if I stop at any given time, I'm not increasing or decreasing towards, right? That's like a point on my interval towards. But from here to like the end of the desk, I am getting closer to, right? It's the same for your points. You're increasing or decreasing on an interval, but any specific point you're not really doing. You're just kind of there. So, any other questions here? Are we okay? All right. Let's go on to number 7. So number 7, we're asking what is the direction of the opening and the max or min value for this quadratic. So anytime you have a quadratic like this, I'm always going to try to put it in your vertex form. So y equals some a of x minus h squared plus k. So I always want to put it in this form first. So I'm going to take this f of x, and I'm going to fix it to put it into that form. So I can fix it and say, well, f of x, that's going to be 2 times negative x plus 4 squared plus 7. That negative, I don't want any coefficient in front of x, so I can factor out that negative. So I have 2 times negative of x minus 4 squared plus 7. And this negative kind of just goes away, right? You can square the negative and take it out. So you have 2 times x minus 4 squared plus 7. So anytime we're talking about properties of a quadratic, always put it in this form first. And once you have it in this form, then we can start talking about its properties. So from here, the direction I'm opening, well, what I will do first is always kind of draw a rough sketch of the graph. I have a positive a value, so I know I'm going to open up, and I have a vertex of 4, 7. So anytime we're talking about the properties of a quadratic or properties of any graph, what I would do is always draw like a little rough sketch of the problem right here. Like just a really rough sketch, doesn't need to be perfect. And then from there, once you have it drawn out, you can start to figure out, well, what properties do I have? Well, I can see that I'm opening up. And my max or min value, if I look at my little rough sketch that I drew, I have a minimum. I have my k value 7. And we can even go as far to say, well, where am I increasing or decreasing? If I look at the rough sketch I have right here, I can see that I'm increasing from 4 to infinity. And I'm decreasing from negative infinity to 4. Any questions about that? Are we okay with that? All right, let's keep going. Example 9, find the average rate of change for this quadratic over the interval -3 to 7. So for this, what we're going to figure out first is I need to figure out what are the y values for this -3 to 7, right? The -3 to 7, that's your x intervals, the interval from an x value -3 to an x value 7. So the first thing I'm going to do is figure out, well, what's f of 3, or f of -3, sorry. So f of -3, I can plug it in for x. I have 2 times -3 minus 4 squared plus 7. -3 minus 4 is a -7. Square that plus 7. From there, 49 times 2 is what, 98 plus 7. And that's 105. So what that tells me is I have a point of -3, 105. And now I'm going to do the same thing with the other point of 7. So I have 2 times 7 minus 4 squared plus 7. We'll solve this out. 7 minus 4 is 3. 3 squared is 9. 9 times 2 is 18 plus 7. That's 25. So my other point is at 7, 25. So the first step here is always figure out your 2 points. And once you have your 2 points, then you want to use your average rate of change, which is y2 minus y1 all over x2 minus x1. Yes. To be honest, I'm not sure if these are the same problems. The same problems. There's, I think, a few more different ones, but I mean, it's also because module 3, the quiz is pretty much the same as the test, right? Because it's the same thing. The quiz was 3.1, 3.2. The test tomorrow is 3.1, 3.2. So we kind of similar, yeah. But I can go a little faster. We can go to some new stuff, I guess. So for this one, y2, we can say it's 25 minus 105. All that over 7 minus negative 3. So when I do that, 25 minus 105, that's 80. On the bottom, 7 minus negative 3, that's a positive 10. That gives you 8. That's your average rate of change. It should be negative 8, you're right. All right, any questions about this? Are we okay? All right, let's keep going. Thank you. All right, so number 12, write a statement describing the transformations on R that give you T is what we have. So what I'm going to do is I'm going to fix it up first, put in that quadratic form. Right, I want to put in the form y equals a times x minus h. Just in the right. Plus k. So that's the first thing I want to do. I want to fix this equation to be in that form. So I can rewrite this as 2r of negative 4x over 3 plus 5, all plus 6. I can factor out that negative 4/3. So when I factor out that negative 4 over 3, I'm left with x. And then to factor out negative 4 over 3 with 5, you multiply with its reciprocal. So with negative 3 over 4, you get negative 15 over 4 plus 6. Everyone with me so far? Are we okay? And then from here, let's have the transformations. So this 2, that tells me I have a vertical stretch by 2. The negative 4/3, that tells me I have a horizontal compression by 3/4. Remember, that's 1 over b. So 1 over b is negative 4 over 3. B is 3/4. And the negative tells me I have a horizontal reflection over the y-axis. And then from there, 15 over 4, that tells me I'm going to the right by 15 over 4. And that 6 tells me I'm going up by 6. So anytime you can, fix the equation so it's in that form. Y equals a times x minus h plus k. I guess this one you don't really need actually the square. And then go from there. Any questions about that? Does that make sense? Go ahead. So it's not, the negative doesn't actually compress or stretch it. All this is reflected. So your B is negative 3 over 4, but the negative gives you the horizontal reflection I have here. And then the 3/4 is the compression, right? So they kind of, it affects the x's, but it's just that the negative doesn't compress or stretch, it just reflects it. Any other questions here? Are we okay? All right, let's keep going. Number 5, Write the equation for g of x if its graph is formed by reflecting f of x across the x-axis, then horizontally stretched by a factor of 6, and lastly translated 5 units to the right and 3 units down. All right, so in this case, I'm starting with this f of x, and I'm going to apply these transformations on it. So the first one I have is across the x-axis. So you reflect something across the x-axis, what you're doing is you're vertically reflecting it. So when you vertically reflect something, you're affecting your a and your k. So what I get is that my new graph is f of x is going to equal -3 now times 2 over 3 x plus 2 squared, and now it's going to be a plus 7. Your negative is going to affect both your a and your k, so that's why the 3 becomes a -3, the -7 becomes a +7. After that, I'm going to be horizontally stretched by a factor of 6. So the horizontal stuff gets a little tricky. So anytime you have a horizontal reflection or horizontal stretch or anything horizontal, you always want to put it directly with the x. And this horizontal stretch by a factor of 6 tells me that b is 6. So what I put into the equation needs to be 1 over 6. So f of x is now -3 f 2/3. I'm going to put that 1 over 6 directly with the x. Then add 2 and square it, plus 7. And once I put that 1 over 6 with the x, then I'm going to factor it out. I know putting the 1 over b value with the x can seem like a lot of work, but I do it just so I make sure I don't make any little mistakes or kind of do something wrong. So when I factor out that 1 over 6, I get 2 over 18. And then when I factor out a 1 over 6 out of 2, what you're going to do is multiply 2 with its reciprocal. So 2 times 6 is going to give you 12. Right, and that also kind of makes sense where I'm stretching it by a factor of 6. So my h value 2 ended up becoming an h value 12. And then lastly, I'm going to go 5 units to the right and 3 units down. So f of x, that's going to equal -3. That 2 over 18 can become a 1/9. And then I'm going 5 to the right. So if you're going 5 to the right, that means you're going to subtract 5. Because remember, your h is 5, so you put in a -h. So you have x plus 7, all squared, and 3 units down, that 7 becomes a 4. Any questions about that? Does that make sense? Ready to keep going? All right. All right, we're on 15. What is the value of p that completes the square of 16x squared minus 48x squared is 6 plus p? So for that one, what we want to do is we want to use the formula that b over 2 squared equals a times c. So you do need to know this. And that's the formula for it. B over 2 squared equals a times c, where 16 is your a, -48 root 6 is your b, and your c is p. So I'm just going to plug everything in. So I have -48 root 6 all over 2, all squared. That's my b over 2 squared. That's going to equal a times c, so that's going to equal 16p. So inside this parentheses, I can reduce it down. -48 times 2, or sorry, divided by 2 is -24. Root 6 squared equals 16p. I personally would not take the square root of both sides, just because you're going to be getting a calculator, so you might as well just put it in. And also, if you can simplify something down. If you have like the square of a number, you might as well just figure it out rather than taking the square roots. Right? Also, you have the negative square root in there, so be kind of confusing. So from there, -24 root 6 all squared. That's going to give you 3,456. And that equals 16p. Divide both sides by 16 to get the p by itself, and p ends up being 216. Any questions about that? Does that make sense? Ready to keep going? Is anyone still copying? All right, let's keep going. Now we're on number 19. So number 19, what is this f of x in vertex form? So for vertex form, you need to complete the square here. So I'm going to isolate the first two terms first. So I have negative 2 over 3 x squared plus a 16 over 3x plus 7 over 3. And I don't want any a value in front of my x squared. So I'm going to take this negative 2 over 3 and I'm going to factor it out. So when you factor it out, I have negative 2 over 3. Inside the parentheses, I have x squared. You factor out a negative 2/3 out of 16 over 3. You multiply by the reciprocal, so you have 16 over 3 multiplied by negative 3 over 2. That gives you a negative 8x. And I'm going to have some blank. And I have the 7 over 3 on the outside. And whatever is in that blank, I'm going to subtract it outside too. Right? I have to keep the equation even.
It's now 3 o'clock. If you have been a coach, director, sponsor, or in tutorials of a teacher, you must now exit the building. Thank you.
All right, so I want to keep this equation balanced. I don't want to change the value of it. So when I put it here, I need to subtract as well. So it goes in the first blank right here. That's b divided by 2 squared. So in this case, that's 16. Right, negative 8 divided by 2 is negative 4. Negative 4 squared is 16. And what goes in the second blank is going to be my a value that I pulled out. Negative 2 over 3 multiplied by what I put here, 16. So what I get is negative 2 over 3. This factors out to x plus b divided by 2. My b is negative 8, so we divide it by 2, you get negative 4, all squared. And then I have 7 over 3, and I'm going to subtract it with negative 2/3 times 16, which is negative 32 over 3. And this ends up just you adding these two together to give you that f of x is negative 2 over 3 x minus 4 squared plus 39 over 3, which just reduces down to 13. So you have 39 over 3. That just becomes 13. That's going to be your answer. Any questions about that? Are we okay here? Ready to keep going? All right, let's keep going. That's going a lot faster than I expected. All right. So 21, expand to convert this into standard form. So to expand it to put into standard form, all I'm going to do is take this x minus 3 all squared and expand that out. So if negative 5, x minus 3 squared, that's a factoring pattern. So if this is a minus b, it's going to convert, or it's going to FOIL out to a squared minus 2ab plus b squared, all plus that 4. So you plug that in, what you end up getting is a squared minus 6x plus 9, all plus 4. Or you could just do the box method, whatever you want. Just x, you have to figure out what x minus 3 squared is. Distribute this negative 5 in, negative 5x squared plus 30x minus 45 plus 4, or negative 5x squared plus 30x minus 41. And that's going to be your final answer. Any questions about that one? Are we okay? All right, let's keep going. Now we're on number 28. So write the quadratic function that has an axis of symmetry of x equals negative 2 and passes through the points negative 3, 2 and 0, negative 13. So with these problems, you need to figure out what are they telling you, and also what do they give me. They tell me that h is negative 2 because your axis of symmetry is always x equals h. So my h is negative 2. So when I put it into my vertex form, I have f of x equals some a that I don't know times x minus my negative 2 of x plus 2 squared plus some k that I don't know. Right? Anytime we try to figure out the vertex form, I need a, h, and k, but they only gave me h. So I need to figure out what's a and k going to be, and I can do that by using these 2 points. So when I have the point negative 3, 2, I can plug that in and get that 2 equals some a times negative 3 plus 2 all squared plus some k. And that can reduce down to 2 equals a times negative 3 plus 2 is negative 1, squared is just 1. So it's just going to be a by itself, all plus k. And then for the other one, 0, negative 13, I can do the same thing, plug it in. Negative 13 equals some a value of 0 plus 2 all squared plus k. 2 squared is 4, so I have negative 13 equals 4a plus k. So I have two equations. They have the same a and k value, so I can make a system of equations out of them. I can say 2 equals a plus k, and negative 13 equals 4a plus k. And then from here, I want to cancel out the k's, so I can subtract them from each other. 2 minus negative 13 becomes a positive 15. A minus 4a is negative 3a, and the k's cancel out. That was the whole point of the system of equations, to cancel out the k's. So what I get is that a is negative 5. So I figured out my a value, and now I can take it and I can plug it into either one of these two equations, the green or the purple one, it doesn't matter. But I'm going to plug it into the green one because it'll be a little easier. So I get that 2 will equal my a value of negative 5 plus k, or that k is 7. So I figured out my a and my k. All I need to do now is go back to the original equation and plug it all in. So I get that y will equal my a value of negative 5 times x minus my h value of negative 2. So x plus 2 all squared plus 7. And that's going to be your final answer. Any questions about that? Does that make sense? All right, so we have one more problem left. It's going to be a word problem. Ready to keep going? Is anyone still copying? All right, let's keep going. So now number 34. For number 34, I'm told an arrow is shot from a height of 7 feet towards a target 300 feet away. The arrow reaches a maximum height of 61 feet after traveling 180 feet towards the target. I'm going to write a function modeling the height of the arrow. If the target is sitting on a mound 26 feet tall and has a diameter of 4 feet, will the target hit the arrow? All right, so something like this, I'm always going to draw a picture just to kind of understand exactly what's happening. So I have this graph right here, and I'm told that an arrow is shot from a height of 7 feet towards a target 300 feet away. So I know that there's a little longer. There's some target way out here that's 300 feet away. I also know that at 7 feet tall, an arrow is shot. And I'm also told that the arrow reaches a maximum height of 61 feet after it travels 180 feet towards the target. So I know that the highest the arrow gets is 61 feet, and that happens a little over halfway at 180 feet towards it. Right, so I know what happens for sure is something like this. I'm going to hit that maximum height and start going down, but I don't actually know if the arrow is going to hit the target or not. That's actually what it's asking me. It's telling me this target is sitting on some mound, 26 feet tall, and the target has a diameter of 4 feet. And I want to figure out, well, is it going to hit the target or not? So before I worry about even if it's going to hit the target or not, what I'm going to do is figure out the equation of this quadratic. So I have 2 points. This point right here is 0, 7, and this point right here of 180, 61. Right, those 2 points I know for sure exist. And those 2 points I can use to figure out what's my quadratic is going to be. Right, because 180, 61, that's your vertex, that's your h and your k value. So I know that f of x, or h of x, or whatever you want to call it, is going to equal some a value that I don't know, times x minus my vertex, or minus my h value, which is 180, all squared, plus my k value of 61. And then from there, I can use the point 0.07 to plug in and figure and actually solve for my a. So when my y is 7, my x is going to be 0. So I have a of 0 minus 180 squared plus 61. I can subtract the 61 over, and when I do, what is that? Negative 54 equals a of 180 squared, negative 180 squared. So whatever 180 squared is, I'm going to figure that out. There's 32,400. So negative 54 equals 32,400 times a. Divide that over. I get that a is negative 54 over 32,400. Those are both divisible by 4. So 32,400 divided by 4 is going to give you 8,100. 54 divided by 4. Is it divisible by 4? No, it's not. But they're both divisible by 2. Or they're both divisible by 9, actually. Sorry. So 32,400 divided by 9. There we go. That's 3,600. And that's 6 on the top. They're both divisible by 3. Or actually by 6. So you get negative 1 over 600. There we go. So my a value is negative 1 over 600. So I can take that and plug it back into the original equation. And I can say, well, f of x, that's negative 1 all over 600 times x minus 180 all squared plus my k value 60. Right, so that's my, what's it called? My vertex form of this quadratic. So that's what's going to represent this whole thing right here. This whole scenario that's happening right here, this equation is going to represent it. So what I want to do from here is I want to figure out, well, is it actually going to hit this target when the target is on top of a mound that is 36 feet tall or 26 feet tall? So at 300 feet, there's some mound right here that's 26 feet tall, and there's a target on top of it. Everyone with me so far? So what I want to figure out is I want to figure out, well, what y values do I actually have to do? Right, this mound is 26 feet tall, and the diameter of the target is 4 feet tall. So what I want my y to be able to hit the target, because the target's going to go from here to here. Like this is a terrible drawing, so don't even worry about what it looks like. But it's going to go from this blue dot up to that blue dot. So what I want is I want my y value to be between 26 and 30. Right? Because it's on top of a hill that's 26 feet tall, and it's 4 feet tall. So that diameter of 4 feet. So the target is 4 feet tall. So from 26 all the way up to 30, the arrow can hit the target. So I want my y to be between 26 and 30. And I can figure out what the height of the arrow is going to be when I plug in 300 into the equation for x that we just solved. Everyone with me? Are we okay with that? Make sense? All right. So plug in 300. F of x is negative 1 over 600 times that 300 we just got minus 180 squared plus 61. So you have -1 over 600 times, that's 120 squared, plus 61. That's what, 14,400 over 600 plus 61. You just plug that in. So you have 14,400 divided by 600. That's 24. Plus 61 gives you 85. So the arrow is going to be at a height of 85 at the target. Yes, go ahead. Just keeping up my negatives. Negative 24 over 61. Thank you for that. Negative 24 over 61, which that ends up giving you something closer to the target at what, 37? Sorry? 37, okay. So either way, still not going to hit it. So it's 37 is going to be 7 feet too high to hit the target. So no, it's not going to hit it. Does that make sense? So you have to take into account the diameter of the target to determine if it's going to hit it or not. No, really, that's all I had for you guys. Any questions about anything? Are we okay? Sorry if this was kind of just like the same problems I did last time, but we're going over the same exact steps. So, right? This is projectile motion. As what? As wordy? Yeah. I mean, all projectile motions are going to be similar to this. Give me a second. Yeah,